Hi there. I said hello, welcome back. So this time saying hi. Uh, I said in the last lesson, I'm going to introduce you to the binomial instead of expansion, the binomial series. Well, it's again bit of your A2 work. For people in year 13, you would have done this. See, so far, oh, by the way, my name is Sosale Mohana. I am a teacher of maths. I've taught A-level maths for over 50 years now. A-level or its equivalent across 3 continents. India, which is in Asia, Kenya, which is in Africa, and England, which is in Europe. So I have enough background to talk about these things, and I hope these lessons are useful to you. So let's come back. So we're still in topic 3, which is algebra. And then we're now doing the binomial series or binomial theorem. Normally they say general binomial theorem. All the formula books will have that is expansion of 1 plus x power n, where n is a rational number. Let's recollect the definition of a rational number. It can be a fraction, it can be a rational number, and n does not belong to n. That means I'm considering positive fractions of any type. We don't use normally decimal, but if you want to, you could use decimals, terminating or repeating decimals. But you can't use positive integers. It can be a negative integer. -2, -3, -half, -1/3, 4/3, 7/8, anything you want. Which is different from what we learned before, where it was only a positive integer. So the formula is this. Unfortunately, you don't know enough maths at this stage. I mean, you haven't covered enough of the topics to figure out why it is so. But people doing further maths, when you do Maclaurin series, you will derive this formula. 1 plus x power n is 1 plus nx plus n times n minus 1 over 1 times 2x squared plus n times n minus 1 times n minus 2 over 1 times 2 times 3x cube plus etc. 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 The condition is -1 less than x less than 1. We don't use NC1, NC2 here because suppose n is -2. NC1 would be number of ways in which, okay, 5C1 means number of ways in which you pick one thing out of 5 things or arrange 1 out of 5 items in a row, picking one at a time. Or 5C3 means arranging 3, remember I spent a whole lesson, 3 things in a row without repetition out of 5 things, picking one at a time. Sorry, picking 3 at a time. That was the combination 5C3. So what will be -5C3? Number of ways which you pick 3 things out of -5 things. You can never pick a -5 thing. Where is -5 things coming from? That's why we don't use the symbol NC, even though theoretically this NC1, NC2, NC3, the N has a different connotation here. So we are away from the positive integer N. Secondly, remember in the binomial expansion you did, the series would stop when you reach a power n. In this question, in this expansion, your x is 1, your a is x. So you stop when you reach x power n. Suppose this is a power half. X power half. So when are you going to reach x power half? You've got x power 2, x power 3, x power 4, x power 5. You're never going to reach x power half. That means the series will never end. That's why it's a general binomial theorem And when it is not a whole number, positive whole number, you end up getting an answer which has infinitely many terms. Okay? But you don't have to know all that. This is in the formula book. I'll take some examples. Expand. I'll take one example. Oh, sorry, before I proceed. Two rules. This is one. Second one is it must be of the type, the expansion, can be applied only when the question is of the type 1 plus power n. That means it can't be applied when you have 2 plus something, 3 plus something. It has to be 1 plus. Expand and simplify up to and including the term in x power 3. Example 1. 1 minus 2x power minus 2. So, first and foremost, always compare. That is 1, that is 1. That's x, that's minus 2x. That means wherever you have x, you write minus 2x. N is minus 2. Wherever you have n, you write minus 2. This formula is in the formula book as far as UK level is concerned. So, you should be able to copy the formula and use it. So, 1 plus n is minus 2 times x is minus 2x plus n is minus 2 and minus 1 is minus 3 over 1 times 2 minus 2x the whole square plus n is minus 2 and minus 1 is minus 3 and minus 2 is minus 4 over 1 times 2 times 3 times minus 2x the whole cube plus etc. Alright? So therefore, that will be 1 plus 4x. Here 2 and 2 cancels. 2 squared is 4. Minus and minus plus, plus and plus, plus. 2 squared is 4. 4 3s are 12. 12x squared. Here 2 and 3 cancel. Minus and minus is plus. Plus and minus is minus. A minus and a minus makes it plus. 2 cube is 8. 8 4s are 32x cube. And you don't put equal to, you put approximately. It also says state the range of values of x. For which, don't worry, you don't have to copy. As I told you, you'll get the handout. The expansion is valid. Remember, if you have 1 plus x power n, your x must be between minus 1 and 1. But my x is minus 2x, but I'm not bothered about the minus n because actually it is modulus of x less than 1. The absolute value of that x is 2x here, so it should be minus 1 less than 2x less than 1. Divide through it by 2, minus half less than x less than half. Valid for. Or you can say mod x less than half. That was an easy expansion, obviously. So I'm just keeping an eye on the watch, just in case. So I'll take another example. I will rub this off because I hope you know by now you know it. Because this is something which comes very often in the exam. Example 2, it is 2 over 4 plus 3x power half. Going to be difficult. I think 4 plus, let's make it 4 plus. Should I make it 4 plus x? Root 2 over 2 plus x power half. I'm trying to keep it simple. Right. Some of you, obviously I need in the above, so you can't expand at the bottom. You have to write as minus half. Don't do it. First make this 1. So it is root 2 over, let's make it root 8. Root 8 over, remove 2 by force as a common factor. I get 1 plus x over 2 power half. So that's root 8 over 2 power half is root 2 times 1 plus x over 2 power half. Root 8 over root 2 is root 4, which is 2. So 2 times, now take the power up. You understand what I'm saying? Please do not take it up and try to do it, because you might forget. The two errors that happen is you will forget the negative half for 2, and you forget to, generally students forget to take the common factor, or they just remove 2 out without realizing that the 2 also has to be raised to the power half. Be careful. So I need to expand this. So that is 2 times 1 plus n times x plus n times n minus 1 over 1 times 2 x squared. I'll straight away write x squared over 4 plus n times n minus 1 times n minus 2 over 1 times 2 times 3 x cube plus dot 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 dot. So let's open with the 2. Look, minus half and half is minus quarter multiplied by 2 is minus half. So minus half x. You need to be good at, otherwise use your calculator. Here, half and 3 over 2 is 3 over 4. 3 over 2 and 2 is 3 over 8. 3 over 8 and 4 is 3 over 32. 3 over 16 plus 3 over 16 x squared. Then a half, a minus and a minus is a plus. Plus and a minus is a minus. The 3's cancel. In the numerator I have a 5, 2, 4, 8, 16 divided by 2 makes it 8. 8 and 8 makes it 64. Put an approximate sign equal to, or put a dot dot dot. Now validity. You might be expanding this, but you applied the binomial theorem for that. So you say valid for minus 1 less than x over 2 less than 1, or minus 2 less than x less than 1, or mod less than 2, or mod x less than 2. You understand that? So that's one. But then I'll take one more example. I'm trying to make it a bit more complicated. I'm going from easy to complicated questions. Right? Square root of 1 plus 2x over square root of 1 minus 3x. Or let me make it cube root of, should I? Leave it as over 1 minus 3x. Let's not even put any cube root there. Or let's make it the other way around. 1 minus 3x over 2 minus 3x over square root of 1 minus 2x. Right. Please don't try to apply binomial theorem for this particular general binomial theorem for 1 minus 3x, because the power is 1, which is a positive integer, so this expansion doesn't work. Might work, but it doesn't. Let's not use it. Again, this is a 1, so I can safely write it as 2 minus 3x times 1 minus 2x power minus half. Very good. So 2 minus 3x times 1 plus n is minus half times x is minus 2x plus n is minus half n minus 1 is minus 3 over 2 over 1 times 2 minus 2x the whole squared plus n is minus half times n minus 1 is minus 3 over 2 minus 5 over 2 over 1 times 2 times 3 minus 2x the whole cube. And more, and no more than. So it's 2 minus 3x times, you need to be good at first simplifying. 2 and 2 cancel, so 1 plus x. Here, 2 and 2, 4. 2 squared is 4, 4 and 4 cancels, so I get 3 over 2x squared. Here, this 3 cancels with 3. I've got a 5. Minus and a minus plus, plus and a minus minus, minus and a minus because minus cube is plus. 5, 2, 4, 8 and 8 will cancel. So I'm left with a 2. 5 over 2 x cube. I'll put an approximate sign. Multiply through it by 2. 2 plus 2x plus 3x squared plus 5x cube minus 3x minus 3x squared minus 9x cube over 2. I don't want the x power 4 term. So the answer is approximately equal to 2 minus x, 3x squared will cancel, 5 minus x cube over 2. That's your answer. Now, you didn't use the expansion for 2 minus 3x, but you use the expansion for 1 minus 2x. So, valid for minus 1 less than 2x less than 1 or minus half less than x less than half or mod x less than half. You can't leave it there. You need to bring only an x. Is that clear? So I'm going to stop at that. So I've taken you through the general binomial theorem. Next time I'll take a bit more complicated examples and the types which come in the exam. Okay? Have a nice day. Bye bye. See you. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.